Hello class, and welcome to Module 3 of our lesson on quadratic equations. This week we'll be studying how to solve quadratic equations graphically and algebraically. So let's begin our journey on solving quadratic equations. During this lesson, you will learn the steps necessary on how to solve quadratic equations graphically and being able to find the roots on the graph. Then we will solve the quadratic equation algebraically using the following steps. We will factor, we will then solve the factors, and then we will check the solutions. So let's start with solving quadratic equations graphically. Here are the steps to solving a quadratic equation graphically. First, we must pick x values that will stand as our x coordinates. You can see that I've chosen from -3 to +3 as my x values. Then I'm going to substitute those x values into the equation to give me corresponding y values, which will be my y coordinate. Then I'm going to pair the two together, my x coordinates and y coordinates, and I will graph each point that I have. And then I'm going to look at the graph after connecting the dots to see exactly where the graph crosses the x-axis. Wherever it crosses the x-axis are the roots or solution to my equation. So let's try these steps within an example problem. Our example equation will be x squared plus x minus 2 equals 0. So let's apply our steps to see if we can solve this example equation graphically. Step 1, we pick our x values. And remember, we're going to go from -3 to +3. Now we're going to substitute those x values into our equation to determine the corresponding y values. Here you can see exactly what step 2 is referring to. We have the x values on the left. We plug them into the equation in the middle, and we see what the corresponding y values are. This will give us our x and y coordinates. Now in step 3, since we have our x coordinates, we now have our y coordinates, we just put them together to give us our ordered pairs. For example, -3 corresponds with 4, so that first pair is -3, 4. 1 pairs with 0, so the coordinate pair is 1, 0. At the bottom, you can see all the coordinate pairs from -3 to +3. Now that we have our ordered pairs, now we can graph the equation. We take our points, we put them on the graph, and we connect the dots. Here you can see exactly what the graph x squared plus x minus 2 looks like. This graph actually shows it from -5 to +5, but includes the points from -3 to +3. Now that we have the graph, we can examine it to see exactly where the graph crosses the x-axis. Where the graph crosses the x-axis are the roots or the solutions to the equation. So now we look back at our graph, and we see exactly where the graph crosses the x-axis. We see that it crosses at -2 and +1. So those are our roots or solutions to the equation. What you also may want to notice is that on the right side of the screen, you see when x equals -2, y equals 0. And when x equals 1, y equals 0. So there's a corresponding relation to the roots of the equation being where y equals 0. Now let's investigate how to solve quadratic equations algebraically. Here are the steps to solving a quadratic equation algebraically. First, you must factor the quadratic equation. Then you will solve each factor to find the roots or the solution to the problem. Then you'll plug the solution or the roots back into the equation to ensure that they fit and that they are correct. So let's use our example problem from before but this time we will solve it algebraically. So remember, the equation was x squared plus x minus 2 equals 0. Our first step is factoring the quadratic equation. And from our prior knowledge of quadratic equations, we know that they have two factors. So we know that when we factor this, we should not come out with any more than two factors. Remembering from our earlier lesson on factoring quadratic equations, we try the bust-to-be method first. And that's where you try to find two numbers that multiply to your a and c coefficients that add up to your b coefficient. And so here in our example, we want two numbers that multiply to -2 but add up to +1. And if we play with the numbers, we know that 2 and -1 add up to +1. So therefore, we can use the bust-to-be method. So then we substitute the 1x for -1x plus 2x. So that changes our equation to x squared minus 1x plus 2x minus 2 equals 0. And we're kind of going to split the equation in half. And we'll factor the first two variables of the equation. So out of x squared minus 1x, we know we can factor out an x, and that leaves us with x minus 1. Out of the second half of the equation, if we factor out a 2, that leaves us with x minus 1. And we know that in the bust-to-be method, we should have the same exact expression in both parentheses. We see that we do, so we can kind of throw one out, and we know the factors are x plus 2 and x minus 1. Now that we've factored the equations, step 2 requires that we solve each factor in order to find the roots or the solutions to the quadratic equation. So remember, after factoring, that we found the two factors to be x plus 2 and x minus 1. So we'll set them both equal to 0 and solve for x. So when we set x plus 2 equal to 0, and solving for x, we subtract 2 from both sides, and we get x equals -2. And for x equals 1, when we set that equal to 0, we add 1 to both sides, and we get x equals +1. So our solutions seem to be x equals -2 and x equals +1. Two factors, two solutions or roots. Now that we found the roots or the solutions, step 3 says that we should plug those back into the original equation to make sure they satisfy the original equation statement. So let's check our solutions. First, we have x equals -2. And when we put that into the original equation, we get -2 squared plus -2 minus 2 should equal 0. And after we do some simple algebra, we know -2 squared is +4, and -2 minus 2 is -4. And we know +4 minus 4 equals 0. So that solution checks out. Now let's move on to x equals 1. We have 1 squared plus 1 minus 2 should equal 0. 1 squared is 1, plus 1 is 2, minus 2 gives us 2 minus 2, which equals 0. So that checks. So because both solutions satisfy the original equation, we know that -2 and +1 are roots of the equation x squared plus x minus 2 equals 0. This concludes our solving quadratic equations lesson. If you need further assistance, join me in online tutorials this Thursday, April 29th at 6:30 p.m. Here we will go over the steps again on solving quadratic equations and do some more practice problems. To gain access, simply just click on the online tutorial web link located in the web link section of the course.
I hope that you really enjoyed our lesson today. Remember, there are some things that you must complete this week. First, make sure that you do the practice problems that are associated with this lesson. Then, do the postings based on your assigned equation on the online discussion board. Finally, there will be a quiz, and it's due Saturday by midnight. Enjoy your week, and hopefully I will see many of you on Thursday. Bye-bye.